Copy down your target for today. We're going to be working on writing and evaluating ratios, rates, and unit rates, as well as writing and solving proportions. As 8th graders, you've done this all, especially last year in pre-algebra. You might take it to a little bit of a higher level this year, and it's also a great review. So copy down your target, answer the 2 warm-up questions, then press play. So to start us off, the warm-up, how many inches are in a foot? You should know this. There's 12 inches in 1 foot. We're going to use this idea for a conversion factor later. How many inches then are in 4 feet? You just take the 12 and multiply it by 4. So 48 inches. Okay, before we get into the examples, you're going to have some definitions to copy down. So fill in these definitions. They should sound familiar to you. We're going to go through these notes. I'm going to skip a couple problems, but they're going to be on your quick check afterwards. So you come back after the video and you'll show your work there. A ratio is a comparison of 2 quantities by division. Remember that you can write a ratio as a fraction, a over b. You can write it as with a to b with the colon, or you could actually write out the word a to b. All 3 of those are ratios, but all it is a comparison of 2 quantities by division. A proportion then is a statement that 2 ratios are equal. So you might have a over b equals c over d. It's important with proportions to keep the left side matching the right side, and we'll do an example where I'll explain that a little bit more. You have rates then. Rates are ratios that have 2 different units. So think about a rate. We could say I traveled in the car at 40 miles per hour. That's a rate because I have miles per hour. Or I drink 3 cups of coffee in a week. A unit rate is a special type of rate in which the second quantity is always 1. So those examples I just gave you, the second quantity is 1. 40 miles per 1 hour is a unit rate. So it's a rate, it's also a unit rate. If you need more time on getting these definitions, pause the video. The ratio of the number of bones in the human skull to the number of bones in the ear is 11 to 3. So let's circle that. That's important. What is the 11 standing for and what is the 3 standing for? Well, it's skull to ears. So the 11 is going to be the skull. And the 3 is going to be the ears. And there's really the bones in the skull and bones in the ears. There are 22 bones in the skull. How many bones are in the ears? So when you do this problem, you have a ratio, and we have another quantity, and we want to find out how many bones are in the ears. So this ratio is going to equal another ratio. That's a proportion, guys. Fill in what you know then. It's important when you set up a proportion to keep symmetry in the proportion. So since skull is on top over on the left, I would put whatever number represents the number of bones in the skull on top on the right. Since the number of bones in ears is on the left in the bottom of the fraction, make sure the number of bones in the ears is on the bottom over on the right. There are other ways to set it up, but you want symmetry, whether it's vertically symmetrical or horizontally symmetrical within the proportion. This is the standard way that we do it, so keep them matched up. There are 22 bones in the skull. I want to know how many bones are in the ears. This is my unknown, so I can put an X. Now, how do you solve a proportion? A lot of you probably are going to tell me cross multiplying. You may even have done it already. Cross multiply, and you have 11 times x equals 3 times 22. So you have 11x is equal to 66, and you divide by 11, and you get 6. Put a label in there. What am I talking about? I'm talking about 6 bones in the ear. But why does cross multiplication work? Can you explain that to me? Can you justify why you're allowed to use it? Let's go back to the original equation, okay? We have 11 over 3 is equal to 22 over x. The reason cross multiplication works is because it's like a shortcut. It's actually like a shortcut to what we did when we learned how to solve equations with fractions. If we want to clear those fractions, In the warm-up problem that we did about that lesson, we would multiply by whatever the least common multiple of the denominators to cancel those out. If I multiply both sides by 3x, then I'll get rid of my denominators. Watch. You have to multiply everything in the equation, though, by the 3x, or you won't be keeping the equation equal. Now here on the left, the 3's cancel each other out, and I'm left with 11x. Here on the right, the x's cancel out, and I'm left with 3 times 22, or 66. Do you see why cross multiplication works? You're actually just solving the equation normal. The cross multiplying is a shortcut, so make sure you understand that. All right, let's go on to the next one. Ralph Law of Germany flipped a pancake 416 times in 120 seconds to set a world record. Find the unit rate of how many pancakes he flipped per second. So in this problem, I want unit rate. What is a unit rate? It's a rate where the second quantity is 1. Give me the rate that he's starting at. Well, he has 416 flips for a pancake in how many seconds? 120. To find the unit rate, you get the denominator to be 1. Think of this as a fraction. If you want the denominator to be 1, what would you divide both of them by? Well, 120 would have to be divided by 120. Whatever you do to one, you do to the other in a fraction. So we'd actually be reducing the fraction by 120. Or you could just think of it as doing the division on your calculator. This number is not going to be super easy. You do have a calculator this chapter, so go ahead and use your calculator. And let's round this answer to the nearest tenth. Round to the nearest tenth. I end up getting 3 7/10 flips per 1 second. You could write your answer like this. You could say 3.7 flips per second. You could write the word per. Both of these are good answers. Unit rate, second quantity has to be 1. So divide the fraction, both the numerator and the denominator, by whatever you need to divide it by to get the denominator to become 1. Our next example, we have a little runner here. With this example, guys, we want to convert. So let's see. Serena ran a race at a rate of 10 kilometers per hour. What was her speed in kilometers per minute? Round your answer to the nearest hundredth. Remember with conversions, to show your work. Conversions, we always want to do them in our head. Your teacher wants to see your work. So start with what you have. What is her current rate? This is my first step. What are you starting with? Well, she's traveling at 10 kilometers per hour, or per 1 hour. The second thing I do is I write down what do I want to get to, what do I want to finish with. I actually think about that before doing the work. Well, what is her speed in kilometers per minute? That's what I want to end up with. So let's put that over here. We won't know the number, but we can at least put the units. I want to end up with kilometers per minute. And since it's per minute, I really technically want 1 minute. I always think about what I'm starting with and what I want to get to first. Then I go to the work. That's going to be step 3. Step 3 should be multiplying by conversion factors. What is a conversion factor? Well, conversion factor is a ratio that is technically equivalent in the numerator and the denominator. It's a ratio that technically is like 1. It's not going to look like the number 1 though. So when we think about this, I want to multiply what I have, and if you notice, I want to keep the kilometers, but I want to cancel out the word hours. I want to get it to be minutes. So let's just, focus on what we want to get rid of. I want to get rid of hours, and I want to get it to become minutes. Well, if hours is in the denominator here, in order for it to cancel, hours has to be in the numerator up here. And then you have to think about what you can convert hours to. You can convert hours to minutes, which is exactly what I want. So hours to minutes is going to be your conversion factor. Now what you do is you fill in the numbers that's going to make this equal to 1. Not actually the number 1, but the top is equal to the bottom. So how many hours equals how many minutes? 1 hour is equal to 60 minutes. This is a conversion factor. Okay, that's what I'm talking about. So it's technically equal to the number 1. I hope that makes sense. If you have questions, please ask either your teacher or see the math resource teacher, 7th period. Now the word hours, the units, are canceling out here. They're gone. Take a look at what I would have left. I would have kilometers over minutes. That's exactly what I want. You may need more than one conversion factor to get what you want. So always check after each step. Do I have what I need? I have kilometers, that's checked off. And now I have minutes, that's checked off. Once they're both checked off, I'm ready to just multiply straight across. Fractions multiply straight across, so I have 10 times 1 is 10, and I have the units of kilometers. And 1 times 60 is 60 units of minutes. Reduce this fraction. You want to get it over 1, so you're actually going to divide them both by 60. 10 over 60 is the same as 1/6. What's the decimal of 1/6? 0.16 repeating on the 6 kilometers per 1 minute. So I'll write it over here with my unit. Make sure in all these problems you have labels and units on your answer. Oh, sorry, we're going to round to the nearest hundredth, so I should finish that off as 0.17 kilometers per minute. We're going to skip the next one right now. You're going to do it in the quick check. So after this video, you're going to come back to number 4 about the cheetah, and you're going to do this. This is going to be the first question on your quick check. So do the work right there. Turn the page. We're actually going to skip the next one as well. This will be number 2 on your quick check. So I'll give you the questions again, but this is where you can show your work. Let's move into proportions then. Let's do another one of those real quick. Solve A as a proportion. If you understand why you're allowed to cross multiply, go ahead and solve it that way. Notice that you have 2 terms down here. So when you cross multiply, it's so important, guys, if you see more than just one number or one letter, put parentheses around it. So this is actually going to be 2 times the quantity of y minus 3 is equal to 6 times 7. If you just multiply the 2 by y, you're doing something wrong. So be careful there. Now let's solve this equation. We can distribute that 2, which is going to give me a 2y minus 6 equals 42. Keep going. You should know how to solve this here. Add 6 to both sides. And then divide by 2. And your answer is 24. A proportion is an equation, so you can plug it back in to check. We plug it in, 24 minus 3 is like 21. So 6, I'm saying 6 over 21 is equal to 2 over 7. That's technically true. If you look at this, 7 times 3 would give me 21. 2 times 6 would give me 21. So those are equal ratios or equivalent ratios. Make sure you have the parentheses. All right, B, you're going to try that on your own as number 3 on your quick check. We have one last one that we're going to do together. We're going to do A together. You're going to do 7B and 8 on your own quick check as well. A contractor has a blueprint for a house to draw, a contractor has a blueprint for a house drawn to a scale of 1 inch is to 3 feet. Anytime they give you a scale, start with that. So 1 inch is to 3 feet. I would write it as a ratio in a fraction form because that's always how we show our work. In A, I want to know, I'm given that a wall on the blueprint is 6.5 inches long. How long is the actual wall? I think it helps if you take a second to just think, okay, which one of these represents the model and which one of these represents the actual? When you go back up to the beginning, he says that the blueprint is drawn and 1 inch on the model or 1 inch on the drawing is to 3 feet in the actual thing. Make sure you set up your proportion to match that. You're given 6.5 inches. Is this the model or the actual? 6.5 inches is on the blueprint, so that would be the model. What you're solving for is how long the actual wall is, so it's x, and you know your unit is going to be feet. Make sure you put feet on the end when you get your x number. Another proportion, quickly we'll solve this, cross multiply. X is going to equal 3 times 6.5. Don't jump for your calculator, think about it. 3 times 6 is 18. 3 times a half is 1.5. So you have 18 and 1.5, or 19.5. Don't forget your units, feet. So try B on your own and try 8 on your own, and you'll put your answers in under the quick check.